Have you ever thought about the salt on your dining table, sodium chloride, and wondered what holds it together at the atomic level? It's more than just a seasoning, it's a perfect example of ionic bonding in action. Sodium chloride forms when one valence electron is transferred from a metallic sodium atom to a nonmetallic chlorine atom. This electron transfer leads to the creation of two oppositely charged ions. Sodium has an atomic number of 11 with an electronic configuration of 2, 8, 1. That one electron in its outermost shell is loosely held and easily donated. On the other hand, chlorine with atomic number 17 has an electronic configuration of 2, 8, 7, just one electron short of a full octet. So, when sodium gives away one electron and chlorine accepts it, sodium becomes a positively charged ion, spoken as sodium ion and written as Na with a superscript plus, and chlorine becomes a negatively charged ion, spoken as chloride ion and written as Cl with a superscript minus. These ions then come together through electrostatic attraction to form the stable ionic compound known as sodium chloride. Let's dive into what really drives this electron exchange: atomic stability. The sodium atom starts with an electronic configuration of 2 electrons in the first shell, 8 in the second, and 1 in the third shell, spoken as 2, 8, 1. By losing that single valence electron, sodium attains a stable noble gas configuration, 2, 8, just like neon. This electron loss is called oxidation. So we say sodium atom loses one electron to become sodium ion, spoken as Na gives one electron to form Na+. Chlorine, on the other hand, starts with an electronic configuration of 2, 8, 7. By accepting one electron, it also reaches a stable configuration of 2, 8, 8, matching argon. This gain of an electron is called reduction. So we say chlorine atom gains one electron to form chloride ion, spoken as Cl plus one electron gives Cl minus. In short, the desire to achieve the nearest noble gas configuration is what motivates both oxidation and reduction in this process. Now let's examine the processes happening behind the scenes: oxidation and reduction. Oxidation means loss of electrons. For sodium, it's quite simple. The sodium atom with configuration 2, 8, 1 gives up one electron and transforms into a sodium ion with configuration 2, 8. We say sodium gives one electron to form sodium ion, spelled out as Na gives one electron forms Na+. Reduction, on the other hand, is the gain of electrons. Chlorine with an initial configuration of 2, 8, 7 accepts one electron to become chloride ion with configuration 2, 8, 8. We express this as chlorine plus one electron gives chloride ion, spelled out as Cl plus one electron forms Cl minus. These processes happen simultaneously. Sodium is oxidized and acts as a reducing agent, while chlorine is reduced and acts as an oxidizing agent. This electron exchange lays the groundwork for ionic bonding. So what brings sodium ion and chloride ion together? It's the powerful electrostatic force between their opposite charges. Sodium ion, which is positively charged, and chloride ion, which is negatively charged, attract each other and form a strong ionic bond, also called an electrovalent bond. This attraction results in the formation of a stable compound, sodium chloride, which is electrically neutral overall, even though it is composed of charged particles. Let's state the reaction in words. Sodium atom reacts with chlorine atom to form sodium ion and chloride ion. These ions then combine to form sodium chloride. In spell format, Na plus Cl gives Na plus and Cl minus, which combine to form NaCl. Let's now use a visual aid, the electron dot structure, to show how this transfer of electrons actually happens. Sodium has one valence electron, which we represent as a single dot. Chlorine has 7 valence electrons, shown as 7 dots around the symbol Cl. When sodium donates its electron to chlorine, the dot from sodium shifts to chlorine, making it 8 dots around Cl, indicating a full octet. After the transfer, sodium becomes a positively charged ion, represented as an A with a superscript plus and no surrounding dots. Chlorine becomes a negatively charged ion, represented as Cl with a superscript minus and 8 dots. So, the electron dot reaction in words would be sodium with 1 dot plus chlorine with 7 dots gives sodium ion with no dots and chloride ion with 8 dots, forming sodium chloride. This dot diagram captures the entire bonding process in one simple picture. For an even deeper understanding, let's observe the orbital arrangement of electrons before and after bonding. Before bonding, sodium has 3 shells with electrons arranged as 2, 8, 1. Chlorine has 3 shells as well with electrons arranged as 2, 8, 7. After bonding, sodium loses 1 electron and now has 2 shells with configuration 2, 8, like neon. Chlorine gains 1 electron, now with 3 shells in configuration 2, 8, 8, like argon. So visually, sodium goes from 3 shells to 2 and chlorine fills up its third shell. This transformation to noble gas configuration is what makes both ions stable. This orbital change is what enables the ionic bond in sodium chloride. Let's wrap up our journey into the bonding of sodium chloride. Sodium with an electron configuration of 2, 8, 1 undergoes oxidation and becomes a sodium ion with configuration 2, 8. Chlorine with a configuration of 2, 8, 7 undergoes reduction to become a chloride ion with configuration 2, 8, 8. The sodium ion, spoken as Na+, and the chloride ion, spoken as Cl-, are attracted to each other by strong electrostatic forces, forming an ionic bond. This bond gives rise to sodium chloride, written as NaCl, a neutral, crystalline solid with a rigid structure. We visualize this using both dot structures and orbital representations, giving you a clear understanding of how ionic compounds like table salt are formed. I hope this session helped you see how something as ordinary as salt carries deep chemical insights. In the next class, we'll explore more chemical bonds that build the very world around us. Until then, keep observing chemistry in everyday life.